I'm Aroma Revi, the director of the Indian Institute for Human Settlements and an IPCC coordinating lead author. Today, I'm going to tell you how Volume 3 of the AR6 Summary of Urban Policymakers series establishes what the latest science on mitigation of climate change means for cities and urban areas. The global urban population is over 4 billion and will touch 7 billion by 2050, along with a significant expansion in urban land area. This will lead to a rise in demand for resources, infrastructure, and services, and increased greenhouse gas emissions from and because of consumption in cities and urban areas. Hence, urban climate change mitigation has a crucial role in determining our future climate. How cities and urban areas are planned, designed, built, retrofit, managed, and powered will influence urban greenhouse gas emissions over the 21st century. A large share of people in low-emitting countries lack access to modern energy and mobility services. Addressing extreme poverty, energy poverty, and providing decent living standards can help achieve sustainable development in urban areas and simultaneously help reduce global energy demand and limit emissions. Cities in the Global South at an early stage of urban development need new infrastructure and buildings, leading to potentially high material demand and embodied emissions. Established cities across the world, often in the Global North, need to replace or rebuild aging infrastructure and retrofit buildings. To address these complex challenges, we can use an Avoid, Shift, Improve or ASI framework to support climate mitigation across urban and other systems with a new emphasis on demand-side climate mitigation. Avoid actions help limit emissions through individual behavioral and lifestyle changes and redesigning service provision. Shift actions accelerate choices to competitive low-carbon technologies and service provisioning systems. Improve actions help increase end-use efficiency of technologies in and across urban systems. Cities of all types can accelerate systemic climate responses through 5 interconnected system transitions: energy, urban and infrastructure, land, coastal, ocean and freshwater ecosystems, industrial and societal. Urban mitigation actions linked to these system transitions can reach across multiple sectors within and across urban boundaries and regions. Cities and urban areas have a key role in the energy system transition on the demand side and also on the supply side. For example, compact urban form can reduce energy demand. Demand management can increase energy systems flexibility to accommodate a greater variety of renewable energy sources. The urban and infrastructure system transition brings together a range of energy, buildings, transportation, and land use options. The feasibility and effectiveness of these options is mediated by urban land use, spatial form, and the state of urbanization. This includes whether the city is an emerging city, building its infrastructure, a rapidly growing city with new infrastructure, or an established city with existing infrastructure. Land use change contributes to between 13 to 21% of greenhouse gas emissions. The land and ecosystem transition can reduce emissions and climate impacts by expanding local urban green and blue infrastructure and promoting urban farming that limits transport and food waste. Urban land and ecosystems can also be an important carbon sink if properly managed. Cities can play an important role in the industrial system transition through spatial planning that limits material demand, design standards, building codes, efficient material procurement, and reusing and recycling waste. Coordinated value chain decarbonization can help industries reach net zero carbon dioxide emissions. Demand-side strategies across all sectors can reduce emissions by between 40 and 70% by 2050. Societal transitions are needed to accelerate these demand-side strategies and implement the system transitions. There are multiple feasible mitigation options that have synergies with adaptation and sustainable development, such as sustainable urban planning, energy efficiency, and expanding renewable energy supply. Many of these lie at the interface of urban planning and infrastructure design. For example, walkable areas combined with clean energy, networks of green and open spaces, urban forests and wetlands, urban agriculture, and water-sensitive design. Expanding clean energy and public transport can accelerate SDG outcomes around health, employment, energy security, and equity. Enhanced mitigation that shifts development pathways towards sustainability can create new green job opportunities, raise incomes, and reduce inequalities within and between countries. Enhanced mitigation actions can deliver local adaptation benefits like reduced flood risk, limiting urban heat island impacts, and enhanced health because of reduced air pollution. Enabling conditions promote or advance system transitions and ultimately transformation. They play a critical role in enabling widespread, effective, and accelerated implementation. Urban policy and planning, governance, finance, lifestyle and behavior change, and innovation and technology are key enabling conditions. Active governance and coordination at multiple levels across a range of actors and an integrated approach to urban policy is a critical enabler. This includes vertical and horizontal integration of local, regional, national, spatial, and sectoral policies, and a partnership between public and private institutions. Strengthening the financial capacity and creditworthiness of cities can expand the availability and access to climate finance. This is crucial to successful urban mitigation. Cities, in partnerships with national government and international financial institutions and markets, can help mobilize climate finance to enable mitigation and adaptation. Lifestyle and behavioral change are important for mitigation, supported by policy and system changes, appropriate pricing, sustainable technology, and making low-carbon choices the default option. Public support for systemic change improves when benefits and costs are shared and when decision-making processes encourage trust. Cities can implement aggressive and ambitious mitigation policies that contribute to sustainable development. Pursuing mitigation and adaptation actions together can promote climate-resilient development and improve human and planetary health. Our climate is our future.